Good morning, students. These types of questions are quite common in competitive exams, where they ask us a two-digit number or the number obtained by interchanging the digits. So let's learn about two-digit or three-digit number formation, shall we? 9432, that is 9432. If we observe from right hand side, the first digit is called units digit, second is called tens digit, third would be hundreds, and fourth would be thousands. Now, if we try to write the expanded form for this number, that would be 9 times 1000 as it is in thousands place, plus 4 times hundreds as it is in hundreds place, plus 3 times 10 as it is in tens place, and 2 times 1 as 2 is in units place. This is the expanded form for the same number. We have learned this in standard 4th or 5th, alright? Now, what if they ask us to assume a two-digit number? We'll say, let's assume the tens digit to be x and the units digit to be y. Since it is a two-digit number, we'll say we know that we multiply 10 to the tens digit and 1 to the ones digit. That would be 10x plus 1y. But what if they ask us to interchange the digits? That means y would become tens digit and x would become units digit. No worries, let me write two-digit number obtained by interchanging the digits, right? So what we'll say over here is that y should be multiplied by 10 in this case, because y has become tens digit number and x has become units digit number. So let us multiply 10 to y and 1 to x. This is the number obtained by interchanging the place of digits. Simple. Normal number was 10x plus y, and the number obtained by interchanging the digits would be 10y plus x. Alright. What if they ask us about a three-digit number? Very simple is that we'll assume the hundreds digit to be x, tens digit to be y, and units digit to be z. We know that we need to multiply 100 to the hundreds digit number, that is x, tens to the tens digit number, that is 10y, and 1 to the units digit number, that would be z. This is how we assume a three-digit number. I guess we are pretty clear about this. Now let's solve a few questions based on the same. Value of a two-digit number is 5 times the sum of its digit. Alright, so they have asked us a two-digit number. What we'll say is, let us assume a two-digit number, that is 10x plus y is represents equals to, over here 5 times represent 5 multiplied by sum of the digits were x and y, right? This is the equation which we got. If we solve this, we get 10x plus y equals to 5x plus 5y. If we interchange the places, we put some space. If we move 5x to over here, that would become 10x minus 5x, which is 5x, and this would become 4y. Now, the ratio for x and y would be 4 by 5, and as we know that x and y are digits of a number, that means the value of x could be all the way from 0 to 9. It cannot be more than that. Similar goes for y. So we'll assume the value of x to be 4 and y to be 5. X to be 4 and y to be 5. We are asked the product of the digits. That means we are supposed to find xy. We'll say, let's assume x times y. The value for x is 4 and the value of y would be 5, that is 20. Option C. Next question. Similar type of question. They have asked us a 2-digit number. What we'll say is, let's assume a 2-digit number which is 10x plus y is such that the product of the digits is x. We are given the product of the digits to be 8. It says if 63 is added to the number, what was the number? 10x plus y. We'll say if 63 is added to it, the digits interchange their place. The digits interchange their place means the number would become 10y plus x. We have learned that if the number is 10x plus y, on interchanging the digits, it becomes 10y plus x. If we solve this, we get 9x minus 9y equals to 63. We will say, let's take 9 common. That would be 9 open bracket x minus y equals to 63. Let me put some space. X minus y would become 7. Alright, so we have gotten x minus y equals to 7, and we as well were given xy to be 8. We were given the product to be 8, right? Over here. Now, we can solve these two by putting the value of x from over here to over here. We can do that, but that would be too lengthy. We can assume the numbers. It is very clear for me that the value for x would be 8 and y would be 1. That is 8 times 1 equals to 8, and 8 minus 1 equals to 7. So the value for x and y would be 8 and 1 respectively. Find the sum of the digits. We are supposed to find the sum, that is x plus y. That would be 8 plus 1 equals to 9, which is option D. Simple. Now, this is one of the most important concepts, and direct questions have been asked from this section. Sum and difference of a 2-digit number and reversed. As I have already said, the number would be 10x plus y and the reverse number would be 10y plus x. What if we add them? If we add them, we get 11x plus y. We get 11x plus y. Now you can very clearly see that the sum is a multiple of 11. Now, if you wish for an example, let me write, let's say 52 plus 25, sorry. This is the number, and this is the number obtained by reversing the digits. We get 77. You add any number with the number obtained by reversing its digit, it would be a multiple of 11, right? Just keep this in mind, this will be helpful. Now, what if they ask us to find the difference? We'll say, let's take the number obtained by reversing the digits, subtract them, we get 9x minus y. Again, if you observe, this is a multiple of 9. The sum was a multiple of 11, whereas the difference is a multiple of 9. Let's take an example, same example. I'd say 52 minus 25, which gives us 7 and 2, that is 27, which is a multiple of 9. Now let's see a direct question based on this concept. The question states, which of the following can be the sum of a two-digit number and the number obtained by reversing the digits? We know that if we add a number to the number obtained by reversing its digit, it is a multiple of 11. Let's check which of the following is a multiple of 11. Well, I can very clearly see that this is a multiple of 11. How? The sum for 1 and 5 is 6, 9 and 8 is 17, the difference is 11. Therefore, this is a multiple of 11 and final answer. Solve one more question. The question states, when we reverse the digit of a number 14, it increases by 27. That is very true. I don't know what the question is. That is very clear. If we reverse the digit of 14, that becomes 41, and the number increases actually by 27. All right. How many other two-digit numbers increase by 27 when the digits are reversed? It says, let's take a two-digit number. Let's take a two-digit number. If you add 27 to it, the digits gets reversed. How many such number would be there? Well, I can write an equation for this. That would become 10x plus y plus 27 equals to 10y plus x, right? I mean, I just add 27 to the number to get the number obtained by reversing the digits. If we solve this, we get 9y minus 9x equals to 27. Take 9 common, y minus x, 27, y minus x would be 3. Now, as we know that x and y are digits of a number, so the value of x and y would start from 0 all the way up to 9. So we'll take all the possible values of y and x within the given range. Let us assume the value for y and x. We'll write x, y over here, x over here. What can be the possible values of y and x? That would be 3, 0, 4, 1, 5, 2, 6, 3. Similar, it would be 7, 4 over here, 8, 5, 9, 6. These are the possible values of x and y. Now, if you observe, we cannot take 3 and 0. Why? Because our assumed number was 10x plus y. If we assume y to be 0, the entire two-digit number would become one digit. So we'll exclude this section. Now we are left with 6 possible prospects. That is 14. Remember, we are not going to say 41 because the number is 10x plus y. We'll say 14, 25, 36, 47, 58 and 69. These are the possible numbers when reversed increases by 27. But if we observe, 14 has already been talked about. We were already given 14, and the question asks, how many other two-digit numbers. What does other mean? Except for 14. You are not supposed to count 14. Although there were 6 possible combinations in total, it has just asked for all the possible other combinations. So we'll exclude 4 and 1 and we'll talk about just these 5. So our final answer would be 5, which is option B. Tricky question was that, but again, this is a competitive exam. Next question. The question states a number consists of 2 digits So we are asked to assume a 2-digit number such that the digits in the tens place is less by 2 than the digits in the units place. Let me actually reduce the size of this question so as to get more space to write. I guess the question is still visible to you guys. Since we are asked to assume a 2-digit number, I'll assume that to be n, that is 10x plus y. The question clearly states that the tens place is less than the units place. We'll write the tens place, which is x, is lesser than the units place by 2. That is y minus x equals to 2. We are as well set 3 times the number added to 6 by 7 times the number obtained by reversing the digits. We'll write 3 times the number obtained by adding 6 by 7 times the number obtained by reversing the digits. Let's assume the number reversed is n bar equals to 108. Let's put the value over here. The value for n is 10x plus y, and n bar, it would be 10y plus x, which is the number obtained by reversing the digits. If I can, I will divide the entire thing by 3. That would be 3, 6. Multiply the entire thing by 7 as well to remove this section. Now, there are multiple methods. You can take LCM, whatever. We'll multiply this 70x plus 7y plus, that would be 20y plus 2x equals to 36 times 7. If you observe, I have multiplied almost all of them by 7, not this section. Why? Because 7 and 7 gets cancelled. We add them, we get 72x plus 27y, which equals to 36 times 7. Now I can again see that all the 3 terms are divisible by 9. I'll do that. 8, 3 and 4. Well, we get 8x plus 3y equals to 28. Now, we were actually given an equation in the above section, which is y minus x equals to 2. Shall I write this to be y equals to x plus 2? We'll put the value of y over in here. The value of y over in here, that is x plus 2. That would be 8x plus 3x plus 6 equals to 22. 28 over here. 28. 11x would be equal to 22. X equals to 2. Now, the value for y, we know that is x plus 2. That is 2 plus 2 equals to 4. And our number, assumed number, was 10x plus y. Anyway, let's see what the question is asking us. Sum of digits. It is not asking about the 2-digit number. It is just asking for the sum of digits. We can very clearly see that the sum of the 2 digits is x plus y. That is 2 plus 4 equals to 6, which is option C. Simple was that. This was all about the number formation. The number obtained by reversing its digit, and few problems. I hope you liked the video. If you did so, please hit the like button and do visit the previous videos on the number system as well as PYQ series. Have a good day. See you in the next class. Goodbye.